Thank you all for being here. I was a bit scared to come here, so this is a first for me. And also I don't speak a lot of English in my day-to-day, so bear with me for the French accent. And the few French elements on the slide, I don't think there are going to be many, but sommaire is in French. So today I'll be going through a quick presentation of the subject, myself and the team that worked on the investigation. Then a bit about the forensic investigation, the technical analysis of the vulnerability that we discovered, and then a bit about the aftermath and what really happened. So let's get to it. Just a quick bit about myself. I work in Marseille. I came here doing a 6-hour drive yesterday, which was not the best idea. I'm a pen tester. I've been a pen tester for about 3 years, and I do a lot of web applications, purple teaming, Active Directory, all this stuff, and also a lot of code audits because I love programming. I recently passed my OffSec Experienced Penetration Tester certification, and also PASSY in France. And I want to take my BSCP and CRTO certification. So if you have tips, please come talk to me after the talk. And yeah, I work in Marseille. And here's my website that is linked. I wanted to update it with this slide this morning, but it didn't work. So you're going to have this slide, but probably later on today. Here is the team that worked on the investigation. There was Thomas, which was the CSIRT analyst, myself from the pentest team, and Wilfried and Jean-Pascal, which helped get everything along. And so this was a collaboration between the CSIRT and the pentest team, which is nice. So just a bit about CraftCMS, because I didn't know what CraftCMS was before taking on this project. It's very similar to WordPress. It's a PHP-based content management system, so it's just used to make classical websites. It's developed by a small team, which is called Pixel and Tonic, based in the USA, and was launched in 2012. It has many features, and the features that are built in is one of its strengths compared to WordPress, where you have to use a lot of plugins to get things done. It's used by many people. I didn't find a clear number online, but at least 95k instances, and here are a few logos of the people using CraftCMS. Okay, so know a bit about the attack that went on. So for this story, one of our clients was attacked, and their website went down. And so with this server being down, they asked Orange Cyberdefense to investigate. And so this is where we start. So what Thomas did was, he accessed the server. He tried to read through the logs to try and understand what really happened. And so he had access to both, the system logs, the Apache or Nginx logs, and then also the CraftCMS logs. This is interesting because CraftCMS, it is a good and a bad thing. It logs really everything, including for post requests, every parameter going on. And so it's a bad thing for privacy, but a good thing for us because we had everything. So let's get straight to it. He tried to go through the logs, and this is one of the first thing that caught his eye. The first reason being someone is trying to reach an admin root, and it seems to be protected. But the code isn't like for 1 or for 3. The request succeeded in going through. And also it's from a Python script, because at the bottom of the screen, you can see the Python request user agent using an old version of Python. And so when he continued going through the logs, he saw this, which is that the same request was made a bunch of times. And so the interesting thing to note is at the right of the screen, as you see, it's a bunch of 404s and then a 302, indicating that the attacker found something on the server. He continued going through the logs, and the next interesting thing was this, and this should scream to everybody remote code execution, because PHP info is called. So PHP info briefly is just a function commonly used to test for remote code execution vulnerabilities, because you just print some basic stuff about the server. An interesting keyword here is as session, and we're going to talk more about it later on. I just want to show to you that the user agent here was still Python, but this will change in the future. So we're going to take a look at the payload. So this is just the JSON payload, which was on the previous slide, but shown better. And so here what we see is fnclose PHP info and asset ID 11. And the asset ID is the thing that the guy was trying to brute force on the server. He had to find a valid asset ID before continuing on the attack. And then what we see, the other thing that is interesting is the FN stream part. And so this is because in deserialization attacks, Guzzle HTTP FN stream is a commonly used vector to execute code. Okay, so then he continued going through the logs. And the next thing he saw was this, a first request where the guy seems to store code, but through a get parameter, which is weird. And a second request where it's not as session, but as hack. And this time he seems to pass a PHP session file. So he continues looking at this. And the weird thing is, there is a sequence like this that happens multiple times. And so what we see here is that the guy was trying to fix his scripts against our client server. You can clearly see first the brute force, and then the call to push the code onto the server, and then he tried to access filemanager.php, which is what the PHP code is supposed to drop on the server. And this is funny because the first time he succeeded, he was using a Firefox user agent, strongly suggesting that he was testing in production. So let's get on with the investigation. Later on in the logs, when the guy stopped playing around with our client server, what happened was he uploaded a few files. Here on the screen is wp22.php. We weren't able to understand what it did, but style.php was used to rename filemanager.php to autoload classmap.php, which is just, we think, an attempt to camouflage themselves onto the server. Okay, so now, just to summarize a bit the forensic investigation, the threat actor started attacking the server on the 10th of February this year. Then they continued testing their scripts from the 10th to the 11th. On the 12th, they used the file manager finally to drop some files. And then we think they sold access to the server because there was nothing for 2 days. And then a bunch of IPs started coming in and they messed with everything. And this is what broke the website. And so we think they sold the access. And this is the only reason why an alert was raised. And finally, the attack does not match any known CVE. And so we potentially have a 0 day on our hands. So let's get on with the technical analysis. So this is where I come in. I didn't do anything that was presented previously. And the first thing I did was try to identify the 3 kind of requests that the guy did. So there is a first one to trigger PHP info, a second one to push the code onto the server, and then a last one to trigger the code. What I also did was install CraftCMS. I did a fresh install because this way, if I replicated the vulnerability, I know for a fact that it is within CraftCMS and not within the code that the client added. So the first thing I did was try to trigger the PHP info function. And this failed, but it didn't fail because of an interesting reason. Only it failed because of CSRF validation. And so CSRF validation, you have 2 ways to go about it. Either you do the right thing and you do 2 requests to validate the CSRF validation, or you're like me, lazy, and you simply disable the CSRF validation. And so this is what I did. And I also enabled the development mode, which gave me stack traces, making the problem easier to debug. Okay, so now if we try to do the same request again, we see our PHP info. We have successfully validated that the guy was trying a 0 day against an up-to-date system. This is huge for me at the time because I never had a proof of concept.py on my system, which is a remote code execution. It was a bit weird. So now we're going to try to understand why PHP info was triggered. And so don't be scared. Let's dive into the PHP code, and let's dive straight into the controller code. So here, as you can see, At the top of the screen, there is a get parameter that can be passed, but it's not passed by the attacker. And so we go into the else branch. And here, two parameters are taken from the body and passed first to normalize transform. And so let's dive into normalize transform. This function does a lot of things, but the only interesting thing for us is creating a new image transform. And so we dive into the constructor of this class. It does a few things, but nothing with our payload except for this. And app configure, what it does is a simple for loop. And so this means that with a simple for loop that sets properties on objects, we're able to do remote code execution, which is wild. So just to isolate the problem and validate that I have found the right bit of code to investigate, what I did was stop trying to do curl requests and instead just write a small script which imports the necessary stuff from Craft and then defines the properties. And if you run this, you get a PHP info, which is wild to me. So this is great. We simplified the debugging of the problem because you lose the parsing stuff, the everything, but we still need to understand what is happening here. So we need to dive a bit into Yee's documentation. Why Yee? Because an image transform, which is the class I was talking to you about, extends a model, which really is a Yee's model. And so Yee, it's a widely used PHP library. And so they do a thing where almost everything they do is based on their components, so Yee's components. And so here are some sentences, from the documentation. So components are the main building blocks of Yee applications. The three main features that components provide are properties, events, and behaviors. And so to put it simply, components is just OOP, but on steroids. It's classical OOP, but with some added features. Another thing that we need to understand is configuration in Yee. Configuration are widely used in Yee when creating new objects or initializing existing objects, and this is what we see on the bottom of the screen. Configurations usually includes the class name and also includes a list of behaviors that should be attached to the objects. And so this is what we see here. Class name corresponds to the payload of the guy, where he passes a class to instantiate. And finally, behaviors, also known as mixin, allow you to enhance the functionality of an existing component class without needing to change the class inheritance. To put it lightly, it's a way to add more code to a class without having to edit the class itself, which is very useful. For example, you could add logging to some components without needing to edit the first class. And so the very interesting part here is when we create an object, we have the syntax as behavior name, which makes us think of the as hack and as session we've seen before. So, we still don't understand everything, so let's dive deeper. Let's go into Yee's source code. And so here, we're inside the base component class, and we're going inside the setter of the base component class. So we're only going to look at the setter for the behavior part, because I know it's the interesting part, but I did read everything. And so when you try to define a behavior using a configuration class, the case that interests us is here. And what it does is it tries to validate that the class that you pass is a valid behavior. So a valid behavior is already a class that is within the system. And normally behaviors, you don't have the power to do much of anything. So this is already a win, but not so much. And so what you do once you validate that this is a valid behavior and not just some arbitrary class, you create an object using Yee create object. Just a quick look at the payload of the attacker again. We notice that he passes two classes. The first one is this one, the second one, this one, and the first one matches what we saw with class, and the second one uses two underscores behind it. And Guzzle HTTP we understand. Field layout behavior is just a random behavior from CraftCMS, which I think has to do with the ways the forms are ordered. And so if we try to remove one or the other, then everything fails. And so this is where we're going to understand everything. now we dive into the create object function. And so there is a lot of stuff here, but the interesting part is this function doesn't only support the class key, but also the underscore class key. And so since it takes the underscore class key first, if you specify both of them, I've put the payload here for reference. The first one is only going to be here to validate the setter, and the second one is going to be the real object that is instantiated. And this is wild to me. So a few takeaways from the technical part. The underlying vulnerability lies in Yi, not in Craft. It's a kind of arbitrary instantiation, but only through Yi's configuration. You're not able to do everything, but enough to achieve remote code execution. And also, as long as we're able to set the property of an object, we can achieve remote code execution. And this is huge because this means that not only Craft is, other products than Craft can be impacted by this. And finally, to the right, I've put an excerpt of FNstream, which I've talked about since the beginning. And as you can see, in the destructor function, the fnclose function is called. And so if you put php info as the fnclose parameter, then you execute php info. And this is great, but it still doesn't explain everything because we still don't understand how we're going to be able to call functions with parameters. But just quick notes. This is actually a regression. Yi already suffered from a similar CVE last year, and it did almost the same thing. And it was patched in the version 2.0.50, but it was done so improperly. They forgot the underscore class key. And so the developers, they noticed the error after 2 small versions. And so they released the fix, which is what's on the bottom of the screen. So as you can see, there is not only the class key, but now also the underscore class keys that is checked. And they released the fix, but they didn't assign a CVE to it. And so many things still depended on the old versions. Okay. So now we are going to try to understand how the threat actor achieved arbitrary code execution. And so now that we understand how the first request works from end to end, we're going to understand how the second and the third request works. And we're going to dive into the last one first, because it's the easier one to understand. And as you can see, first it was FNstream that was used, and here it's PHP Manager instead. So let's take a look at PHP Manager, because contrary to FNstream, it's not as widely used in gadgets. I think I found like one issue online in PHP GDC that talked about it, but that was about it. And so if we take a look at the class, we see first in the init function that it calls load. Load calls load from file, and load from file requires a file. And the file is just this, which is a constructor argument. So this gadget gives us everything we need to require an arbitrary file. And so if the PHP configuration had this bit enabled, then we would have been able to just include a remote file. But in virtually all instances of PHP online, this is not the case. And so we need to dive deeper. And this is where we try to understand how the code comes to be on this server without the attacker needing everything else. So, for example, an account, dropping a file, etc., etc. And so, what they do is really clever to me. So first they do a first request to admin/dashboard, and this request is really protected. And so you get redirected to admin/login. But when you get redirected to the login page, the application wants to be nice with you, and then it wants to redirect you to the page you try to visit. And so in the PHP session file, it stores the return URL, which includes the full URL, including the PHP code. And so this is how the guy stored PHP code onto the server. And the thing is, the file name is predictable. By default, it's varlib PHP session ses _, and the ID is just the ID from the cookie. So you have everything you need. And so now I wanted to try and do better than the guy. And so I created my own payload, which is just a simple shell, but then I had it die because otherwise there was some stack traces and everything. And the first thing I do is push it. Then I note the session ID. Finally, I replicate the request from the guy, and I put the same ID. I add my command, and I get command execution back, which is wild. So just a few finishing touches. I added back CSRF validation, which is pretty easy. You only have to parse the HTML, and then when you found the correct CSRF validation token, you simply pass it. I think it's right here as the X CSRF validation token, and everything works like before. So just a quick demonstration. I wanted to try to include this in the presentation, but I'm not good enough for PowerPoint, I think. Here, only 30 seconds. So let's get to it. Here what you have is my proof of concept code in Python, which is in the article published on SensePost. And what I do is I spawn a Craft server, just to show you that it works. I try to access the front page. And then I take my proof of concept code, which is only going to do two requests. First request to push the code and do the CSRF validation. And the second request to execute the code. And we get back Craft for who am I. And so we achieved full remote code execution. Thank you. So just a bit on the nuclei part. I wanted to write a nuclei template to help everyone try to determine if their server was vulnerable or not. And the funny thing about it is I didn't find a way to search for the vulnerability, except for just exploiting the vulnerability. So this is what the template does. It tries to trigger PHP info, and then it matches the license text, which is here on the bottom of the screen. So, a bit about what happened later on after the investigation. First, there was two CVEs that were assigned. First one for Craft, and the second one for YE, with pretty big CVSS scores. Then we tried to work with ONIF, and so what they do is they scan the internet to try to determine the exposure to certain vulnerabilities. And so here, they identified at least 35,000 instances of CraftCMS, and out of them, at least 13,000 matched the vulnerable version. So this is without accounting for like WAF, IDS, IPS, and everything. So this means that on my computer, I had a small Python script for like more than 10K servers, which is wild to me. And out of those, 300 of them already showed sign of compromise. So for example, they showed FileManager.php or autoload-classmate.php being available. And so here what you have is the distribution of vulnerable instances. So first by country to the left, as you can see, it's the United States that has the most versions available. And then to the right, it's the distribution of allegedly already exploited instances online. And so here we see that the United States place shrank a lot, but Switzerland expanded. A small part on the Metasploit plugin that was written. Valentin Lobstein, which I don't know, but he took my proof of concept, which I published in the SensePost article, and he ported it to Metasploit, which is really nice. But since it was published earlier, less than 10 days after the article, I fear that it may have pushed some people to try to exploit this even more. And finally, the finishing touch will be on the MIMO group or MIMO instruction set. So this is a threat actor that actively used the vulnerability in CraftCMS. And so everything that I'm going to show here is not based on my work, but instead based on Sequoia's analysis. And so I just took screenshots from their website. Thank you to them. And so what they do was they published a complete analysis of the campaign from MIMO. And so the things I wanted to say are, first, they started acting before my article was published, so from February of this year. And they tried to exploit every server they could find using a script called alamdar.sh. So they just push a wget or curl command through the RCE, and then they pipe it straight into bash. And so what the script does is it downloads the MIMO loader, The loader is packed, it's a binary, which is packed using UPX, but then it only uses the default settings, and so this makes it trivial to unpack. And then the another binary is developed in Golang, and they didn't care much because the development symbols were not script. So this made the reverse engineering team for Sequoia much easier. What the binary does is first it tries to elevate its privileges, or at least checks that it has elevated privileges. Then it launches a shared library, which it tries to obfuscate using shared library LD preloading. And what the library does is two things. First, it tries to use IP Royal, which is a paid service online, from which you can share your bandwidth, and so everyone can use it. This is commonly used for scrapping, malicious actions, etc. And so they install this. We get the attacker password, which I don't know if it's still valid. I didn't check, but you can check if you want. And also, they install Alamdar, which is also packed with UPX. And what this is a simple crypto miner called XMRig. And so it mines for the wallet, which is shown here. And they're currently, or at the time of writing this, Sequoia found that they only made $10 per week, which is not much, but they received at least $3K in the wallet. And finally, the group is known to deploy ransomware, and so we know that they collected at least 35K from this activity, and some of it may have been linked to the CraftCMS vulnerability. And finally, multiple clues strongly suggest that the operator is based in Turkey, because the guy was first trying the exploit live from his home IP. So, quick conclusion. First, PHP code is scary. Looking at releases is a nice way to find vulnerabilities. There may be way more affected software, because every software that depended on the before the version 2.0.52 was vulnerable. And finally, both CraftCMS and ES teams took us very seriously, which was nice to have, because I hear it's not the case every time. Thank you for having me.
Nice presentation. Does it work? Yes, it works. Sorry. Any question for Nicolas? Digestion time. Nobody. Everything was clear. Nobody. Any comment here? One question in the front row. Gabby.
So all this just for a few crypto dollars? I mean, if you sell it to Pegasus, I guess you will get more than just 30K at the end, right?
I guess so too. And most of the CraftCMS instances online are for pretty big stuff. So I don't know why they didn't target this. The thing that comes to mind is that they stumbled onto the exploit online and then tried to reuse it, but didn't understand how much of important vulnerability it was.
Okay, nice. Another question from Linus. Thank you.
Thanks very much for the very nice talk. Just what would be your tips and tricks for developers to avoid such stuff? I mean, it looks like a standard input vulnerability. What do you think people should take more care of to avoid stuff like that?
I think it's going to be the classic answers of first you do code reviews and you try to keep the commits small, because if you try to add 10,000 lines, then it's a bit hard to review. And also you can include automated source code analysis tools. I don't think it would have coded this, but you can always try. Oh, and finally, you always add regression tests when you fix something. Here they may have coded it if they wrote full regression test, I think.
Great. Thanks again. And an applause.